This equation is similar to what we've done previously. Now, K here represents, because you are going to equate it to dy over dx, when we'll be working out the isoclines, this will actually be our M. If you can compare this with what I've done in my previous videos, I used M in place of K. So for consistency, I'll just stick with M. All right. So in place of K, it's just M. All right. So M here is the slope. And what you're going to do is to equate dy over dx to M. Doesn't matter if you equate to K, so long as you know what you're doing, you should be all right. And remember, dy over dx is y minus 2x. All right. So we are going to use this equation here to find the equations of the isoclines for all these values of M in this case. All right. So what I mean by that is this. So we can go ahead and start working out these values. So for example, at M is equals to -1, y will be equal to 2x minus 1. At M is equal to -0.5, y will be equal to 2x minus 0.5. At M is equal to 0, y will be equal to 2x. At M is equal to 1, y is equal to 2x plus 1. Now all these equations here, all these guys that you're seeing here, this, all these guys are what we call the isoclines. All right, this are what we call the isoclines. All right, so those are the isoclines. Now we need to sketch them on this diagram. So that's actually part A. You're required to sketch these guys. So I'm just gonna choose a line to use, the good color. The first one will be y is equals to 2x plus 1. So that passes through here. That's the gradient, so it's going to be like that. Another one pass through 0. And because they are parallel, it's easier to actually draw them. Another one passes through -0.5. Another one passes through -1. Okay. So I'm going to just draw the corresponding gradients. So for the first one, m is equals to 1. Next one, m is equals to 0. So this one, m is equals to 0. For this one, m is equal to -0.5. For this one, m is equal to -1. All right, now we can go ahead and make our hatch marks. Um, Now for the first one, m is 1, that means the gradient is 1. So at any point on that line, the gradient is 1. At any point on that line, the gradient is 1. And then the next one, the gradient is 0. So at any point, and you can draw as many hatch marks as you want. All right, at any point on that line, the gradient is 0. And then the other one, the gradient is negative 0.5. So steep, but not very. Something like that. And then the other one, the gradient is negative 1, so much more steeper. Okay, so the question, part B, um, they're asking us to, a curve C passes through the point 0, 1. All right, so this is a known point that the curve is passing through. And so it's fine. All right, so sketch C on the diagram. So this curve is passing through this point here. All right. Now just remember, this is this is the point 0, 1. When the curve passes through this point, the gradient is 1. So the gradient is 1 when the curve passes through that point. Now, when I try to sketch, so my curve, when it passes through this point, the gradient should be 1. And maybe it can come up like that. So at that point, the gradient will be 0. And then at that point, the gradient will be negative a half. At that point, the gradient will be negative 1 as it's coming down. So, and then, goes down something like that. So not really exact that, but, something close to that. So remember, these are just approximations. So don't, it can be perfect compared to drawing these functions on technology, on a calculator using technology. So this is just an idea of how this function may look like, all right? An idea of how this function may look like. Now, remember what I said. This is the most important thing. At this point, when the curve crosses this line, the gradient is 1. When the curve crosses this point, the gradient is 0. When it crosses this isocline, the gradient should be 0, must be 0. Here, the gradient must be negative a half. All right, so use your judgment. All right, and here must be negative 1. All right, and that is how you use those isoclines to draw functions.